Alright guys, welcome to your study guide for our Unit 4 test. I'll be going through the even problems. The odds are there in case you want a little extra practice with the answers for those included at the end. I wouldn't watch the video just to get the assignment done. I would try it on your own first and then just come to the video if you get stuck on something or maybe just to check your answers. But without any further ado, we'll get started. So the first question wants us to name the polynomial according to degree and number of terms. Okay, so now by degree, what that means is it a linear function? Is it quadratic? Or is it cubic? And then by number of terms, is it a monomial? Is it a binomial? Or is it a trinomial? Okay, linear means that the highest power is 1, quadratic means the highest power is 2, and cubic means the highest power is 3. Monomial means there's only one term, binomial means there's 2 terms, trinomial means there's 3 terms. So now when I look at this particular problem here, I see that the highest power is a 1, so that makes it linear, and there's only one term, therefore that makes it monomial. So this is a linear monomial. Alright, let's go ahead and check out number 4. We want to name this one as well. Now this one, the highest power is a 3. That makes it a cubic function. And there's 4 terms. Now I didn't give you guys a name for 4 terms, so we could just say cubic with 4 terms. The highest I gave you guys was trinomial. They do have a name for this, but it's so unused, it's not very common that we don't even bother saying it. So we'll just say this is a cubic function with 4 terms. Let's go ahead and take a look at number 6. Number 6 is just adding 2 trinomials together. So we have one trinomial being added to another trinomial. When that's the case, you just need to combine your like terms. So for instance, we have the 4x cubed. That is like the 3x cubed because they both have an x to the 3rd power. So we can add those together. And when you add like terms, you just add the coefficients, or in other words, the numbers in front. So 4 plus 3 is 7, and then it stays as a cube. Let's repeat that with the others. This one's just a number, and when you have just a number, you can combine that with anything else that's just a number. But there are no other terms up here that are simply a number. So we'll just bring this one down the way it is. It doesn't get to combine with anything. Finally, we have the 8x to the 4th. That can be combined with this one. Notice that that one has no number in the front, but that just means it's a 1. So if we add 8x to the 4th to 1x to the 4th, 8 plus 1 makes 9x to the 4th. Finally, we have this guy here, but there's nothing that goes with that, so we'll just bring that down the way it is. So we've got everything added together, but you guys need to understand that they will typically have these things in descending order. That means we go from the highest power to the lowest. So this term has the highest power, so that's going to come first, followed by this term, because that has the next biggest power, followed by this term, and then finally by the -5 there. Constants usually come last. And there's our final answer for that. Go ahead and take a look at this one. Same thing, we have 2 trinomials, but this time they're being subtracted. And when they're subtracted, we're going to distribute the minus sign before we do anything else. And what that's going to do is it's going to change all the signs of the terms in that set of parentheses there to opposite signs. Okay? This set, nothing changes. You only change the signs in the one that has the negative in front of it. So this one stays the same. And now we're ready to start combining our like terms again. So that's the only difference with subtraction, is you need to distribute a negative first. So let's go. 5a to the 4th combines with 5a to the 4th to make 10a to the 4th. 5a squared has nothing to combine with. 2 can be combined with 3. 2 take away 3 is -1. And then finally we have this -2, which has nothing to combine with, so we'll just bring it down. And once again, we want to put this in descending order, so we start with the term that has the biggest power, and we work our way down to the smallest power. And there's our final answer for number 8. All right, so this one is just kind of a little bit more of the same thing. We have 3 trinomials that are being added or subtracted together here. And for each one that has a negative in the front, we're going to have to distribute that into the parentheses. So we're going to distribute a negative into there, and we're going to distribute a negative into here. So the first trinomial will stay the same. The second trinomial, all the signs will go opposite. And same thing with the last one, all the signs will go opposite. Now we're ready to combine our like terms. I've got a 4th power here. I've got another 4th power here, and another 4th power here. So I could put all 3 of those together. 8 take away 5 take away 6 is -3, and then we have our k to the 4th. Next we have a number, a constant, and there is another constant here, just like that. So we can put those together. -7 take away 3 is -10. -7k to the 3rd power. So here's another k to the 3rd. So we can put those two together. -7 and -4 makes -11k to the 3rd. Next we have a 7k squared, which can be combined with this 8k squared. -7 take away 8 is -15k squared. And we'll just put it in descending order. So we have -3k to the 4th minus 11k to the 3rd minus 15k squared minus 10. Final answer there. Number 12. So this is a monomial being multiplied by a trinomial. And when you have a monomial, all you do is distribute it in. So 5 times 7 is 35. The p will not change. It's still going to be p squared because I didn't multiply any new p's into the equation. Next we do 5 times -6, that's -30p. And then lastly we have 25. So that's how you deal with multiplying monomials. You just distribute. Here we've got 2 binomials, and for that we use a box method. Now remember, we've used the box for 2 different things now. We've used it for multiplication and we used it for factoring. On this problem we are multiplying, and when you're multiplying you start outside the box. So 4k minus 6 and 6k minus 1 go on the outside. So keep that in mind, because when we're factoring we do the opposite. We start inside the box and we work our way out. But when you're multiplying you start outside and work your way in. Now we're going to go ahead and fill in our squares. To find this we do 4k multiplied by 6k, and that gives me 24k squared. Why? Because 6 times 4 is 24, and k times k is k squared, because when you multiply 2 letters you add their exponents. 1 plus 1 is 2. All right, to find this box we multiply these 2 numbers together. 6k times -6 is -36k. To find this box we multiply these 2 numbers together. That leaves me with -4k. The last box can be found by multiplying these 2 terms together, which gives me 6. So we start off by writing our biggest term first, or the term with the biggest power I should say. So that would be k squared. Then we can combine these numbers on the diagonal here. Negative 36k plus a negative 4k makes negative 40k. And then finally we have the 6 at the end. And there's my final answer. Here we have a binomial being multiplied by a trinomial. When that's the case, we need a bigger box. We need a 2 by 3 box. We need it to be 3 spaces long for the trinomial and 2 spaces high for the binomial. And we're just going to go ahead and multiply to fill in our box here. So this box will be 2x to the third. The next one will be negative 7x squared, 5x, negative 16x squared, 56x, and negative 40. And now we're going to take the terms out, starting with the highest power. Then the next one is the x squareds. There's 2 of them here, and we can combine those together. Negative 16 take away 7 is negative 23x squared. The next biggest power is the x's. There's 2 of them here. Once again, we'll combine them. 56 plus 5 is 61x. And then our last one here is the negative 40. And there's our final answer there. All right. Now, we could do the box method on this one, but what I want you guys to notice is that this is a shortcut. And I'm going to use the shortcut, but the box will work. When you have a situation like this, where the 2 terms are exactly the same, it's just that one's a positive and one's a negative, all you do is multiply the first terms, and you multiply the last terms together, and you're done. So, I'm going to multiply my first terms together. Negative 2p times negative 2p is a positive 4p squared. Then we have positive 1 times negative 1, which makes negative 1. And we are now done. That's not the only shortcut we've learned. We've also learned another shortcut. And that's whenever you're squaring a binomial. When you square a binomial, that means you're multiplying a binomial by itself. And once again, we have a shortcut for that. You could use the box method, but the shortcut for that one is you do the first term times the first term. Negative 7x times negative 7x is 49x squared. You do the last term times the last term, which is positive 25. And then this is the interesting part. You multiply the 2 numbers in the middle together, negative 5 and negative 7. That makes negative 35x. But then you're going to double it. And once you double it, you get negative 70x. It's not as nice as the last shortcut, but it's still a shortcut. If you don't want to use it, you don't have to. It can just save time. You can always just do the box method. Now we're moving on to factoring. The directions tell us what to do here. We're just going to take out a GCF. So when you take out a GCF, you're going to have something on the outside, and the 3 terms that you have will be changed once we take that thing out. So what can we take out? Well, first of all, we got to ask ourselves, what goes into 24, 28, and 20? What's the biggest thing that goes into all 3 of those? Well, it would be 4. But another thing we talked about how is if your first number has a negative in the front, you want to take out a negative 4. So what I'm going to do is I'm going to divide all of these numbers by a negative 4. So negative 24 divided by negative 4 is 6. Negative 28 divided by 4 is 7. It's going to be a positive now because a negative divided by a negative is positive. And then 20 divided by negative 4 is a negative 5. Now we can also take out some ends. Notice that this one has 5 ends, this one has 3 ends, and this one has 2 ends. So how many ends can we take out? Well, you could take out however many they can all give. They can all at least give 2 because they all have at least 2 ends. So I'm going to take out an n squared. If I take two n's away from this one, it's going to be left with 3. If I take two n's away from this one, it's going to have 1 left. And if I take two n's away from this one, there won't be any n's left at all. And so there's my final answer. All right, guys, that brings us to our second factoring method, the difference of squares. So anytime you have two perfect squares that are being subtracted, you could always break it apart in the following manner. You split this number up evenly. You split this number up evenly. You make one a plus and you make one a minus. So let's do that here with this one. So what multiplies by itself to make r squared? Well, that would be r times r. What multiplies by itself to make 1? That would be 1 times 1. You make one a plus, you make one a minus. And that's the difference of squares method. This brings us to our third factoring method, the box method. So anytime you have a trinomial, we're going to try to factor that using the box method. I guess I can make that a little bigger. We put the first term in the top left box. We put the last term in the bottom right box. Next, we look for two numbers that would multiply to make x squared, and that would be x times x. Then we look for two numbers that multiply to make -6, and we'll put those here and here. I'm going to try 3 and 2. The next thing we do is we go ahead. Now I know that one of those are supposed to be negative, but I'll get to that in a minute. I like to do the signs at the end. So now we fill in the box. This would be 3x, this would be 2x. Now we know that our guess is right if we could somehow combine these together to get the middle number. Is there a way that you can combine 3 and 2 to get -1? Yes, there is. If you have 2 take away 3, you'll get -1. So that means this 3 needs to be negative, which means this 3 is negative. And my answer is therefore going to be x plus 2 and x minus 3. We're going to do two other ones of the box method, and they're just going to gradually become a little bit more challenging. Let's go ahead and start with this one. For this one, first of all, I notice that they have a GCF, so I'm going to take a 3 out of there first. That'll make things a little bit easier. So 6 divided by 3 leaves 2. 3 divided by 3 leaves 1. And then 9 divided by 3 leaves 3. Next, we're going to do the box method on this part that remains. And when I'm done, I'm going to have my 3 in the front still. And then the box method will give me these two results down here. So we put the first term here in the top left, last term here in the bottom right. We look for two numbers that multiply together to make 2a squared. That would be 2a and a. And then we look for two numbers that multiply together to make 3. That would be 3 and 1. Now 2 times 3 is going to be 6, so we get 6a here and 1a here. Now I know I'm right if these can somehow be combined to make -1. Is it possible to add or subtract 6 and 1 somehow to get -1? Well, the answer is no. So that means my guess is wrong. Now the first change you'll make whenever your guess doesn't work is we're going to keep the numbers 3 and 1, but we're going to reverse where they're located. So I'm going to put the 3 here and the 1 here. All right, so let's fill in our box and see if that works now. Is there a way I can combine 3 and 2 to get -1? Yes, there is. If I have 2 take away 3, which means the 3 is negative, so put a negative here. And now we have our answer here. We've got a plus 1 on the top and 2a minus 3 on the bottom. So this one was a little challenging because, first of all, I had to take out a GCF, and second of all, because my first guess didn't work, so I had to try another guess. Let's go ahead and take a look at another one here. Do we have a GCF on this one? I think we do. I can divide a 4 out of all of that. Then we're going to do the box on the trinomial that remains. And when we're done, we'll have our 4 and then 2 binomials being multiplied together. So we put our first term here, last term here, and we're looking for 2 numbers that multiply together to make 10n squared. I'm going to try 10n. Well, actually, I don't like to do the big ones first. I'm going to try the small ones. Let's do 5n times 2n. We also have a 6 down here. Now, 2 times 3 makes 6. Now, I'm going to write this, but I know that's not going to work. And now, you guys can try it and see if it works or not. It's up to you. But I did give you a little hint in class that I know this isn't going to work because you should never have any GCFs here. Notice how they have something in common. So I know I can't put the 2 there. So I'm going to try putting the 2 here and the 3 here instead. And let's see if that works for us. Is there a way I can combine 15n and 4n to get 11? Or negative 11, I mean. Yeah. If the 15 is negative, then I can get negative 11. So that means this 3 would be negative. And now we have our answer. 5n plus 2 and 2n minus 3. That's the last one I have for the trinomial ones. But just to remind you, if just switching the numbers around doesn't work, sometimes you have to try completely different numbers. Like instead of 2 and 3, we could have also did 6 and 1. Or instead of doing 5 and 2, we could have done 10 and 1. But sometimes you get lucky, and sometimes you got to keep looking. All right. Notice that this one has 4 terms. When it comes to the polynomials that have 4 terms, we're going to use the box method again. A little bit different. You still put the first term in the front, in the top left. You still put the last term in the bottom right. The other 2 terms go in there, and the order doesn't particularly matter. And now to find the numbers on the outside, we really don't have to guess. We can actually just calculate. So what do these 2 numbers have in common? What can I divide out of the 35k cubed and the 7k? Well, both of those can be divided by 7, and they both can have a k taken out. It's like a GCF. How about these guys? What can I take out of here? What do they have in common? Well, they're both negative, first of all, so I could take out a negative. Also, they can both be divided by 4. I can't take any k's out of there, though, because the 4 doesn't have a k to give. Next, we have, oops, that's not what I wanted to do. Next, we have this row. What can we take out of here? Well, it looks like they can both give up 2 k's, and also 35 and 20 can both be divided by 5. So I can take out a 5, and I can take out a k squared. The last row, notice these 2 have nothing in common. So if they have nothing in common, then we just put a 1 there. It's always good to go back and check to make sure this actually works. Does 5k squared times 7k actually give me this? Yes, it does. Does 5k times 4 actually give me this? Yes, it does. Does 1 times 7 give me this? Yes, it does. Does 1 times 4 give me this? Yes, it does. So now I know that this is correct. We have 7k minus 4 being multiplied by 5k squared plus 1. Now we're going to be talking about solving equations. And for this, we're going to use something known as the zero product property. If this times this equals 0, then that means that either 6x minus 1 equals 0, or x plus 5 equals 0. And so we'll just solve both of these. To get our answer. X equals negative 5 and x equals 1/6. Okay. Now this one is not in factored form, so I have to start by factoring it. And I have to ask myself, well, how do I factor this? Well, notice that we always start by looking for a GCF. Do they have anything in common? They do. They both can have an x taken out of them. After that, I don't see any factoring that can occur. Now that I've factored it, we take each factor and we set each one of them equal to 0 and solve. This one's already solved, but as for this one, we got to do a little work. And we get negative 8/3. Taking it up a notch, sometimes before you factor it, you need to put it in standard form. That means we need to move everything from one side of the equal sign to the other so that it equals 0. So I think the easiest way to do that is if I add 8r first. That gives me 4r squared plus 27r minus 40 equals 0. Once it's in standard form, then you can factor it. This is a box method because it's a quadratic trinomial. I don't see any GCF that I need to take out, so I'll just jump right into the box method. And I don't know the answer in advance. I'm just kind of guessing and checking. I'm doing math in my head and I'm seeing that 2r is not going to work. So I'm going to try 4r and 1r. If you're wondering what math I was doing, remember how I said that you can't have any GCFs on the top rows or the outside rows there? Well, if I put 2 in both of these spots, I was going to get a GCF no matter what I did. So I know that 2 can't go there. All right, so I'm going to try 4r and 1r. And let's go ahead and try 5 and 8. Let's see if that works for us. 32r and 5r. Is there a way I can combine 32r and 5r to get 27? In fact, there is. If the 5 is negative, then I have 32 take away 5, which is 27. So that means my negative goes here. So factoring, we get r plus 8 times 4r minus 5. Then we do zero product property. And solve each one. So I get r equals negative 8 for that one. For this one, if we add 5 on both sides and then divide by 4, we get r equals 5/4. And there it is. And then we got one more, the long division problem. Now, the types of problems I'm going to give you can be solved with either long division or synthetic. You decide which one you want to do. I'll do it both ways because I don't know which one you're going to prefer. So I'll start off with the long division first, and then I'll show you the synthetic division. I think most of you will prefer the synthetic division. So if you don't want to watch this and you just want to fast forward to the synthetic, that's fine with me. But just in case there's someone out there who prefers this, I'm going to go with it. So first I asked myself, what times x would give me 8x to the third power? Well, that would be 8x squared. Next, I'm going to multiply that 8x times both of these and put my answer on the bottom. So 8x times 8, actually, it's supposed to be squared there. 8x squared times x is 8x cubed. 8x squared times 9 is 72x squared. Then we go and change the signs and add down. These cancel. The first one should always cancel. 76 take away 72 is 4x squared. And then we just bring the rest of them down. After that, we repeat the process with the result. So now I ask myself, what would I have to multiply x by to get 4x squared? I would have to multiply it by 4x. So now I multiply that times both of these, and I get 4x squared plus 36x. Then we're going to change the signs. So this becomes a negative and this becomes a negative. These cancel out. This is a negative x, and then we bring down the 14. And as soon as we end up with a term whose power is less than, or this power, we stop. So it's not less than yet. They're actually equal. So I can go one more step here. Now I have to ask myself, what would I multiply x by to get negative x? Well, that would be a negative 1. So we multiply that here and here. That would give me negative x minus 9. Then we change the signs and add down. These cancel. That's negative 5. And now I don't have any more powers left, so that's where I stop. And this is my remainder. So my answer is going to be this top part here, plus the remainder over the divisor. Now, just so you guys know, if your remainder is ever negative, they may take this negative and just move it here and replace the positive with that. But that's our answer. Okay? Now I'm going to do the same problem, but with synthetic division. A little bit less work. I think most of you will prefer this. The first thing you do is you take this number and change its sign and put it out here. The next thing you do is you take the coefficients only and put them at the top. Next, we bring the 8 down. We multiply the 9 times the 8, and we get 72, and we put that right here, but it's negative 72. And then we add these together. 76 take away 2 is 4. Then we multiply these together. That's negative 36, and we put it right here. Then we add down, and we get negative 1. Then we multiply these together. I get negative 9. And actually, let me back up. If I multiply this times this, I don't get negative 9, I get a positive 9. And so negative 14 and 9 leaves me with negative 5. This number here is my remainder. This number here is my constant. This number here is my x. This here is my x squared. And so we have 8x squared plus 4x minus 1 minus 5 over the divisor. Okay, so that's the synthetic division method. And that will do it. So hopefully that was helpful, and we'll see you guys in class.